It was a normal day in a library. Then suddenly, the alarm sounded. The alarm was not the sound of a fire alarm, but that of an RFID sensor set up by the library. It has detected an unregistered book. Thanks to the sensors, the library was able to catch someone who did not return it. These RFID applications have become more ubiquitous in the last few decades. They offer a promise to speed up the systems in many industries. RFID stands for Radio Frequency Identification. This technology allows for wireless, unique identification of things without line of sight or physical contact. RFID do similar tasks as barcodes. They are both used to track objects and store information inside the objects. However, they offer advantages over barcodes. The RFIDs are durable, are able to scan different objects at the same time, and have better security than barcodes since they cannot be duplicated easily. Thus, they are used to replace barcodes in different sectors. Because of recent advancement, this kind of technology has been becoming more popular and more accessible as the manufacturing processes for it becomes cheaper. You can see this kind of technology popping up everywhere and is the driving force for the development of the Internet of Things. RFIDs may seem recent, however, this kind of technology has been used for the last few decades.
RFID technology was first developed around the time of World War II. During that time, radars were widely used since they served as a form of communication with the aircrafts. However, using these didn't give them the certainty of knowing whether the signals they were getting were of their own or the enemy's. Because of that, they came up with an alternative way to differentiate the signals that they had received. The British conducted a secret project led by Watson Watt, who developed a system wherein each of their planes had a transmitter. So whenever their planes received signals from the ground, the transmitter would broadcast a signal that allows their ground troops to identify them as friendly. In the 70s, a tracking system was devised by the Los Alamos National Laboratories to allow them to monitor their nuclear materials. With this system, they were able to track the route of the transportation of these materials. RFID tagging was first patented in 1973 by Mario Cardullo, wherein it was described to be able to hold information that was rewritable. In 1973, Charles Walton patented the RFID pass card, in which one can unlock a door simply by swiping a card. However, it wasn't until the 80s that this system was recognized. Although he is known as the creator of RFID, Walton was not the first to come up with RFID technology. However, when he came out with his own concept, his design created buzz and he was able to get it patented in 1983. His patent and design were then used as a basis or as an inspiration for later innovations. Because of this, Walton is considered to be the inventor of RFID and is widely known as the father of RFID. In 1970, he presented his RFID technology with the passcard concept to the board of General Motors, but unfortunately, his idea was rejected. In spite of this, he launched his own company, Proximity Devices. His first RFID-related invention was a device which transmits a frequency that activates a keycard once the card is within proximity. Some of his later inventions were then based off of this, one being his first successful project, the electronic door key, which was a design that Walton used in coming up with the product he worked on with the Slade Shock Company. After all his accomplishments and contributions to the world of technology, his design became the basis of many of the keycard systems we have today. It is because of his clever design that we are able to use this technology with ease.
Radio frequency identification technologies use electromagnetic radio waves to automatically identify objects and people by capturing data from specialized tags. An RFID system fulfills this function using three main components: the reader antenna, and the tag. An RFID reader, or interrogator, is a device that can read from and write to compatible RFID tags. It is the device that interfaces with a human or computer operator and connects to the software system that stores and processes the data it collects from tags. The reader antenna is the device connected to the reader that acts as a bridge between the tag and the reader by receiving and transmitting radio frequency waves. The area between a reader antenna and one full wavelength of the RF wave emitted by the antenna is called near field. The area beyond that is called far field. RFID systems operating in low frequency and high frequency use near field communication, whereas those in ultra high frequency use far field communication. Near field signals reduce in strength proportional to the distance cubed, while for far field it is distance squared, making far field ideal for long distances. The heart of the RFID system is the RFID tag, which is a device that can store and transmit data to a reader. RFID tags are made up of two main components, the integrated circuit or IC and the antenna. A tag's integrated circuit houses the tag's memory for storing identifying data, a modulator for radio signals, and the logic unit for implementing communication protocols. A tag's antenna allows it to receive and send back data to the reader in the form of radio waves. Tags are mainly classified based on whether they contain an onboard power supply and may be passive, active, or hybrid. Passive tags are RFID tags without an onboard power supply and rely on the radio waves from a reader to power it. This makes it necessary for the reader to initiate communication. When in the presence of a reader, a passive tag's antenna draws out energy from the radio waves through physical coupling. A power rectifier present in the IC converts this energy into direct current usable by the other components of the IC. Through a process called backscattering, the radio signals received by the tag are reflected back to the reader, but only after the modulator in the IC has encoded information stored in the tag's memory onto the signal. Active tags, on the other hand, have an onboard power supply and onboard electronics that rely on said power supply apart from the usual antenna and IC. This allows an active tag to determine data such as temperature, process this data, and store it into its own memory. More importantly, a power supply allows an active tag to broadcast radio waves without relying on power from a reader and does not rely on backscattering. Instead, it can actively power itself to emit radio waves from its antenna. An active tag can either be a transmitter or a transponder. Transmitters actively broadcast signals even without interrogation from a reader, and are usually coupled with a passive reader that does not have to emit its own radio signals. Transponders, however, enter a low-power sleep state in the absence of interrogation and do not constantly broadcast radio signals. A transponder wakes up and emits its signals only when it receives appropriate command signals from a reader, saving energy and reducing RF noise in its environment. There are also hybrid tags, which have an onboard power supply to power sensors and processors to extend its functionality. Unlike an active tag, however, hybrid tags do not emit their own radio waves and rely instead on backscattering similar to passive tags. This allows hybrid tags to respond to interrogation faster than passive tags because it does not have to use the initial radio signals to excite and power itself, while still using less energy than an active tag would.
RFID technology has been widely used in various industries. There is high efficiency to the processes that implement this technology today. The automation it brought provided a more secure system and more accurate results since the possibility of human error is lessened. Here are some of the real-world systems that use the RFID technology. Toll collection. Toll gates are now capable of automated transactions with the road users because of the RFID technology. The drivers have RFID tags on their vehicles, and when these tags are read in the gates, it will allow them access at the entrance, and the charges will be reflected to their accounts when they pass the exit gates. This has resulted in the shortening of queues in the toll gates. Animal tracking. The RFIDs have been used to protect and manage livestock. For example, cows in the Netherlands have been tagged with RFIDs for monitoring and process automation. These tags are durable enough to withstand the sun and rain. When a meat contamination happens, these RFID tags can be used to trace back which batch of meat it came from. In some cases, identify which animal it was part of. They can also identify where a disease came from in an event of an outbreak. Library management. Libraries use the RFID technology to aid them in the inventory system of the books. The RFID tags on the books serve as its identification. Keeping track of the book whenever it is borrowed is now automated with the help of these tags. The inventory is also easier and more accurate since the personnel does not have to manually count the books. Access control. RFIDs have been used in key cards that are commonly used in hotels or condominiums. Only the residents or official guests have the access to use the elevators and enter the rooms. They tap these key cards to the reader so that access will be granted. These key cards add more security to the visitors by deterring thefts. Casino chips tracking. Cheating and theft has been a big problem in the casino industry. Casinos currently embed their chips with sophisticated markings, making it hard to counterfeit. Now, they are looking to tag these chips with RFIDs. These kinds of chips allow casinos to become more secure and track customer spending habits. The casinos are able to profit more while reducing the chance of people successfully pulling off crimes within their establishments.